Good morning, everyone. Mr. Bencharsky back. Today, we are going to be jumping into our final part of our circles unit. So we started with circumference or perimeter of circles. We went into area of circles, including a number of different types of word problems. And now we're going to get into our final section, which is circle graphs. Now, this isn't a unit on drawing circle graphs. This is a unit on understanding and analyzing circle graphs. And it requires you to have a pre-knowledge of percent conversions. And we've already done these. We started them way back in September when we did decimals to percents and percents to decimals. So as long as you do that, you'll be fine. You also need to know how to multiply decimal numbers, which again, we've been working on since September. So you should be okay there as well. So today I would suggest following along, maybe copying a few of these examples down. The three examples I go through today are identical to ones you're going to see on the first couple worksheets that are going to be handed out to you. So it doesn't hurt to have these down, or feel free to just keep going back to the video. So today we're going to look at our basic circle graph. Okay, so here is our basic circle graph. Now you have to forgive me, I'm drawing a lot of these using the sort of shape tool, so forgive me if they're slightly off. For example, I'm looking at this and I realize 15% in here is smaller than 15% here, and I get that. The problem is it's really hard to sort of design these properly, especially quickly, because a lot of these I'm making quick for you guys. So a circle graph is a graph that represents data using sections of a circle. I mean, it's pretty straightforward. You guys have all seen circle graphs before at some point in your life. Sometimes they're called pie charts, but again, they look like this. Now, each one of these sections is called, well, a sector. And all it is a section from a circle that is formed by two radii, or one radius and then another radius, which we call radii. So each part of this is called a sector. And the total of our circle graph has to equal 100%. Otherwise, it's really not a true circle graph. Now, a circle graph shows how each category or each sector compares to the whole. So whenever we do a circle graph, you will always see a total at the top of whatever that happens to be. So if it's a circle graph of, let's just say, how many students walk to school, you would have a total number of students here, and the percents always have to equal 100. The sum of all the percents in a circle graph must always equal 100. In grade 8, some of you will be doing a unit called understanding graphs, and sometimes they'll show circle graphs, and if you actually add it up, they're greater than 100, which means they're not a proper graph. So all the graphs that you see here should equal 100%. Otherwise, they're not really a true circle graph, and they can't properly be represented. So again, simple circle graphs are graphs that represent data with a circle. Each part of it is called a sector, and it has to equal 100%, and the graph compares what's being on the graph to a total number that should be given to you, and it will in the examples you see here. So we're going to look at a very, very basic example, and this is a student's day. So we're looking at Denham's typical day of 24 hours. So of course we know a day is 24 hours. So whenever it says day, it should always be 24 hours because that's what it is. Now let's go and take a look at this graph here. So we have a 100%, it should total. So if I look, I have 50 plus 30 is 80. 90, it does equal 100%, and we know it's under 24 hours. So this is a perfect graph that we can go and analyze. Now, obviously, this is kind of a joke, and I had a student a few years ago who I sort of bugged that he played too much video games, and this was sort of a joke with him. But video games, 50% of the day, school, 30% of the day, eating, 10% of the day, sleeping, 10% of the day. Clearly, we know that most people don't do that. Sleeping is a lot more than 10% of the day, and video games are a lot less than 50. But again, a running joke. But either way, we can still analyze this graph here. So let's take a look. The first question, and this is a question you're going to see a lot when we do this unit, is what activity does Denham spend the most time on during the day, and how many hours? So clearly, we don't need to do any work for which activity does he spend the most time on, because we can see it. It's right here. It's half of the day, or 50%, which is video games. So the first part here should be, what activity does he spend the most time on? Well, you would simply write down video games. There's nothing else to do. There's no work to show. There's nothing. It asks you a very simple question, and you can see it without actually having to do any work. Now, how many hours, though? That might require some work. Now, on a graph with 24 hours and a very easy number to work with, this is an easy number to figure out. So, for example, if he spends half of his day, or 50%, on video games, and the day is 24 hours, how many hours is that? Well, we just have to ask, what's half of 24? And that, of course, would be 12. So we would put video games at 50%. And I'm going to show you how to do this with more complicated numbers. It's really easy to do with a number like 24 or 10 or 8 or something that's a very easy number to work with. A little bit harder when it's 476 or something of that nature. Now, and it's also a little bit harder when it's not exactly 50%. So to calculate how many hours Denham spends playing video games, we have to convert the percent to a decimal. And this is the first step we have to do with any of these questions that ask us how many of this or how many of that. Because all we're seeing is percent. We don't exactly know how many people that is, or how many pizzas were sold, or how many anything. So the first thing we do is turn 50% to a decimal. And most of you probably know that 50% as a decimal is just 0.50. Now, percent means out of 100, so we divide 50 by 100. And that's all we do when we turn a percent to a decimal. We're just dividing by 100. Now, since percent is always out of 100, we just need to move our decimal 2 places to the left. So 50 divided by 100, the decimal would presumably be here because it's out of 100%. We move it 2 places, and we end up with 0.50. So, again, you guys already know how to do this. This presentation was sort of designed for people who don't know how to do that yet when I first made this. But either way, 50% becomes 0.50, okay? 0.50. Now, we're not done yet. The second part of this is to take our decimal number and multiply it by the total. So next we multiply 0.50 by 24 hours in the day to get the amount of hours Denham spends playing video games. Okay, so we take 0.5 times 24, and it's going to give us 12. Now again, most of you did this with mental math. You just simply said, well, 24 hours, half of that is 12. Great. And if you can do that, that's awesome. But in a more complicated graph that has larger numbers or different percents, you're going to need to do it this way. You're going to need to convert the percent back to a decimal and then simply multiply it by the total. I've had kids say to me, well, why don't I just multiply 50% by 24? Well, if you multiply 50 by 24, you're going to get a lot more than 12. You're going to end up with a huge number. So you have to multiply the decimal variant. 0.50 multiplied by 24 gives us a total of 12. How many hours does Denham spend in school? Okay, well, let's go back to our graph. We're going to have to do a little bit of scrolling here. So Denham spends 30% of his day, according to this graph, in school. 30% of the day. So let's go back down here and let's figure this out. How many hours does he spend in school? Well, the first thing you have to do is turn that 30% to a decimal. So we're going to turn 30% back to a decimal, and that equals 0.30. And again, a lot of you know how to do this already, so this is kind of an easy step for you. We're just dividing by 100 because its percent is out of 100, and we're turning it to 0.30. Now, the next thing we need to do is multiply 0.30 by the total of our graph, which is 24 hours. So we take 0.30 and we multiply by 24, and we get 7.2. Now, that being said, when we're dealing with whole things like hours or pizzas or cars, we often don't want to have decimal numbers. So be prepared to round a lot of these to the nearest whole number. So here, 7.2 would round to 7. So he spends about 7 hours of his day in school. Okay. Now, in reality, we spend about 6.5. So this is actually not super far off from the reality of things. If you want to include the time it takes to get to school and back to school, it probably is closer to 7, for some of you at least. Now, the last one is, how many hours does Denham spend sleeping and eating? Okay, well, let's go back to the top and figure that out. Well, he spends 10 hours sleeping and 10 hours eating. Now, because we're finding both of them, we can just combine these together. So 10% and 10% is 20%. So we just need to figure out the 20%. And apparently that's not on here, but that's okay. I think I can draw it in. Let's see how my pen skills work here. So the first thing we need to do is take our... Wow, it's really hard to do this with a mouse. Kudos to all those YouTubers who can do this with without any problems. They're probably using a better program. 0.20 or 20% as a decimal is 0.20, and then all we need to do now is multiply that by 24 hours in our day. Okay. Now, another interesting way to look at this problem is if we look here, we had 7.2 hours for school, and we had 12 hours for his video games, which would give us a total of 19.2 hours, which means this would just be the difference between the two of them. But either way, you could do it whichever way you feel like. If you take 0.20 and you multiply it by 24, you're going to end up with 4.8. Or simply rounding it up to 5. But he spends about 4.8 hours of his day eating or sleeping. I hope most of you spend more time sleeping than 4.8 hours, but I don't know, maybe you play a lot of video games, who knows. Either way, that's how we do these types of questions. Now we're going to go and do another example here, and this one is different. This is books signed out during the summer. So this is a library who's broken down what they've done, or what books they've given out into 4 categories. And there's a total of 4,000 books that were signed out during the summer. Science fiction was 40%, mysteries at 25%, teen at 20%, and an undetermined amount of other books. Okay, so let's go through the questions here. How many books were signed out were teen? How many books signed out were teen? Sorry. All right, so we do the same process before. We look at teen. Teen is 20%. All right. So first of all, we convert 20% to a decimal, which gives us 0.20. And now we simply have to multiply 0.20 by the total number of books that were signed out, which was 4,000. And that gives us a total of 800 books. So 800 books were signed out, were teen books. Now, how many were science fiction or mystery? All right, so we go back here. Science fiction or mystery. All right, so we have 40% of science fiction and 25% were mystery for a total of 65%. We need to figure out that. So you could do this separately, or I would simply suggest adding them together. But either way, they both will give you the same answer. One just requires a slight more work than the other one. 25% as a decimal is 0.25, and when we multiply that by 4,000, that's a quarter of 4,000, which gives us 1,000 books that were considered to be mystery. Now, science fiction had 40%, which as a decimal is 0.40, and when we multiply that by 4,000, we end up with 1,600, for a grand total of 2,600 books were either science fiction or mystery. So again, take your percent, turn it to a decimal, and multiply it by the total. And this will give you how many of what that is. And our last question, what percent of books are considered others? Well, for this one, we just need to look at our graph. Remember, graphs are out of 100%, so all of these need to equal 100%. So we had 40% plus 25%, and that gives us 65, plus 20 is 85%. So what's missing here is the difference between 85% and 100, which is 15%. Now, on my answer down here, I took 40 plus 25 plus 20 to give us 85, and I took away 85 from 100 to give us 15%. 15% of the books were other. We're going to do one final example here today, and this is daily pizza sales. It's our final example. And there were 293 pizzas that were sold during this week. And if we look at the graph, 25% of those were vegetarian pizzas, 45% were pepperoni, 15% were 3 meat, and an indeterminate amount were other. Indeterminate amount, sorry. Not undeterminate, that's not a word. How many 3-meat pizzas were sold? All right, so we're looking at 3-meat, 15%. So we turn 15% to a decimal, which gives us 0.15 or 15 hundredths. And we multiply that by the total number of pizzas, which was 293. And we end up with a random number here of 43.95. We'd probably want to round that to the nearest pizza because I don't know what 0.95 or 95 hundredths of a pizza would look like. And if we did, that would be a total of 44 pizzas. So there were 44 3-meat pizzas that were sold. How many more veggies were sold than 3-meat? Okay, well, we already know the 3-meat. There was 44 of them. So we need to find the veggie now. So let's go to veggie. There's 25%. So let's turn 25% to a decimal, which gives us 0.25. Let's multiply that by our total of 293 to give us a total of 73.25, and let's round that to 73. So there were 73 vegetarian pizzas and 44 3-meat. So how many more of these were sold? Well, we just need to subtract them. Take away the 3-meat from the veggie, and that will tell us how many more were sold. So there were 29 more vegetarian pizzas were sold. So be very careful, guys, when you're reading these questions. Sometimes they actually don't even require you to do any work. They just need you to look at the graph. And sometimes they'll say how many more than the other. So just be careful. What is the percent of other? So if we go back up here and we look, okay, so we have a missing category here. But remember, the total has to equal 100 for the percents. So 45 plus 25 is 70, plus 15 is 85. Oh, this is the same as the last one. Look at that. 15%. 45 plus 25 plus 15 is 85. And 100% take away 85 leaves us with 15% left over. So that's what we have to do. Guys, there's a lot more we can do with this, but this is the basics of it. Take your percent, turn it to a decimal, multiply it by the total, and that gives us how much of each percent, or what each percent actually represents of the total. Doing this is what we call finding percent of a number. Okay, we're finding the percent of a specific number. So in this case, it was 293. So 25% of 293 is 73.25, or just 73 pizzas. And we're going to keep going with this unit for a little bit. This is not a super large part, but after this, we are done and moving on to another unit in math. This is it for circles. There will be one more video coming up with some word problems, but this is it. Thanks, guys. Hopefully you're doing okay. And if you need to get a hold of me, message me. We can one-on-one do some math on Zoom together and try to figure things out. Talk to you soon. Bye now.